everyone. Welcome to the class of Quadratic Equations, Chapter 5 of Class 10 ICC Board. Now, as discussed in the last class, we are going to solve quadratic equations by Sridhar Acharya's method, or just say that's the formula method. Okay, not by using that splitting of middle term and expressing the left hand side into linear factors. Now, we are also going to say the nature of roots of a quadratic equation. Initially, I was thinking of including two exercises in this class, but as I saw it is going to take more time, so I decided to have at least one exercise in this class. Okay. We have seen that a quadratic equation like this, ax square plus bx plus c equals to 0, has two roots, right? Or two solutions, we say. So x has got two values for which this quadratic equation, this is the general form. Okay, this is the general form. Now x has got two values which satisfies this equation. Okay, and the formula is this. We need to remember this formula, that's x equals to minus b plus or minus root over b square minus 4ac by 2a. Now, how do we get this formula? From the general equation, we just use this method to find out the formula, or say value of x in terms of other quantities here in the equation. So if you just try to find out x in terms of other terms, so what we get, this is the process, like we shift or transpose c to the other side, so we get minus c, and then we try to keep the left hand side as a square of something so that we can separate x later. So how do we, so this is the process. You have to multiply by 4a on both sides, that means on the left hand side. So if I multiply 4a, we have to multiply 4a with both the terms, and on the right side also you have to multiply 4a. Okay, now what you get, you can write it in this a square plus 2ab plus b square. So in this format, when you can write, that becomes a plus b whole square. Now this is the process of getting square on both square on the left hand side. You can pause the video and you can just go through the terms so that you will understand. Anyway, this derivation is given in the book, so you can always go through. There is another method or alternative method given in the book also, that's 2x plus b, like square. If you remove it, you get root over this. So you know that root over something, suppose root over 9, what is the value? It is not only 3, we get plus minus 3 square is also 9, that's why we get plus minus. So hence we write plus minus root over b square minus 4ac. Okay, and hence this term x equals to minus b plus minus root over b square minus 4ac, and 2a comes to the denominator. Now once you take plus, so you have minus b plus root d by 2a, and the other one you take minus, so minus b minus root d. And what is d here? D is b square minus 4ac, and d is known as discriminant. Okay, so this d decides the nature of the roots of the equation. So what you are going to do is you are going to memorize this formula. It's very simple to memorize actually. Once you practice, it will be easier for you to remember. So as I said, the discriminant d equals to b square minus 4ac. Now d decides the nature of the roots. How? Let us see. What do you mean by nature? It means whether the roots are real or not real. I mean imaginary. Whether the roots are equal or two different roots. Okay, so since we have two roots, they may be equal or not, they may be real or maybe not. Okay, so the first case what we have, if this d equals to 0 or b square minus 4ac equals to 0, then that means root over d equals to 0, and root over 0 is 0. So we have the roots. We have two roots, right? Minus b plus 0 by 2a and minus 0 by 2a. So we get both the roots which are equal and they are real. So we get real and equal roots. Okay, so when this d is equal to 0, we get real and equal roots. Now when d is greater than 0, that means b square minus 4ac is greater than 0. So we have root over d, that will be a positive value, right? So root over a positive number. If d is a positive number, say 4, so root over d will be 4. Root over 4 is 2. So root over d is 2. Say something, you take any positive value, you will get some positive value here. So let that positive value be v. So that means x will be minus v plus v by 2a and minus b minus v by 2a. Okay, so what you are doing is, once you are adding the positive number and once you are subtracting the positive number, so whatever you get, those numbers are real and they are different from each other. So they are distinct and real roots when d is greater than 0. Okay, so these are the conditions. Now let us see the third and the final condition. And that's when d is less than 0. What do you mean by less than 0? That's a negative number. So what you say, those roots are, or say the value, this value is not real and that's imaginary. Okay, so x is what? X is minus b plus some imaginary number, and once you are subtracting the imaginary number, so whatever you get, that's actually imaginary. So you cannot find the root of a negative number. So whenever you get d less than 0, so you don't have to solve, you just say roots are not real. Both roots, they are not real. Okay, so these three conditions, d less than 0, d greater than 0 and d equals to 0, decides the nature of the roots. Okay, now let us go and solve the questions. Here is our first question of exercise 5.3. So you see 256x square minus 32x plus 1 equals to 0. So when you compare this with the general form of this quadratic equation, what do you get? This part 256 is a, and b is not only 32, it has to be minus 32. Okay, since we have plus bx, so we have to consider this minus sign along with this 32. This whole thing is b. Okay, and c is plus 1. So we just need to put those values in the formula. We have the formula x equals to minus b plus minus root over, in short you can write d, everyone knows it's b square minus 4ac by 2a. So minus of minus b, so b is minus 32, that means minus of minus 32. Remember, don't get confused, minus b, so minus and b is minus 32. Now you can just put the values. B square is going to be same all the time, whether it is positive or negative. So you have b square means 32 square minus 4 into a is 256 and c is 1 divided by 2a. Sorry, a is what? A is 256. So that's minus of minus 32, that's plus 32, plus minus, we have root over 32 square is 1024. Okay, and this one is minus 4 into 256, that's 250 into 4 is 1000, and 6 into 4 24, so that's 1024. 2 into 256, that 512. Okay, so that's 32 plus minus, this becomes 0 by 512, and that's, we have both the roots are equal, so 32 by 512 and 32 by 512. So when you simplify this part, you get x equals to 32 goes 16 times, so 1 by 16, sorry, and you have to write it 2 times. So x equals to 1 by 16 and both the roots are equal. Now let us see this question. Again we have A 25, B 30 and C 7. So you can just put the values in the formula. So x equals to minus b plus minus root over b square minus 4ac by 2a. Be careful, it should not look like 6, right? It should. So minus of 30 plus minus root over b square, so 30 square is 900, minus 4 into 2500 into 7, so you get 700. That's 2a. A is 25, right? So 2 into 25, and that's minus 30 plus minus root over 200. 200 I can write it as 100 into 2, so 10 square into 2. Okay, so 200 can be written as 10 square into 2 by 50, and that's minus 30. So 10 we can take it out, 10 root 2 minus 30 plus 10 root 2 by 50, or we have minus 30 minus 10 root 2 by 50. Okay, so that's minus, we can take 10 common again, so we have 10 minus 3 plus root 2 upon 50. The same thing here, 10 minus 3 minus root 2 upon 50. So we get two solutions, and those are are 10 goes 5 times, so minus 3 plus root 2 by 5 and minus 3 minus root 2 by 5. So those are the two solutions or roots for the given equation. So here we have a root 3, b is 10, and c is again minus a root 3. Okay, so x equals to minus b plus minus root over b square minus 4ac by 2a. That's right. So putting the values, we get minus of 10 plus minus root over b square, 10 square is 100, minus 4ac, that's 4a is root 3 and c is minus 8 root 3. Okay, so be careful when you put the signs, because here you have to put minus and you are multiplying this whole term. Okay, so by 2 into a, that's 2 root 3. So what you get is minus 10 plus minus. Now if you see minus into minus, I get plus. Okay, so 100 plus something, what is that? 4 into 3, root 3 into root 3 is 3, 4 into 3, 12 into 8, 96. So 100 plus 96, that's root over 196. So by 2 root 3, that's minus 10 plus minus root over 196 is 14. So to remember the simple square roots, and 2 root 3. So what we get, the two roots, we get minus 10 plus 14, how much? 14 minus 10 is 4, 4 upon 2 root 3, and the second one is minus 10 minus 14 is minus 24 upon 2 root 3. Now we don't keep irrational numbers in the denominator, so we have to multiply both numerator and denominator with root 3. Okay, so then we have multiplying both numerator and denominator by root 3 and cancelling or simplifying the other term. We get 2 goes 2 times and we multiply with root 3, so 2 root 3 3. Okay, we multiplied root 3 into root 3 is 3, and in the numerator we have root 3 and 2 goes 2 times. So the other number, again root 3 being multiplied, in the denominator we have 3, and in the numerator you have 2 goes 12 times, so minus 12, and we have root 3, so 3 goes again. This one you have 2 root 3 by 3, and the second one is minus 4 root 3. So these are the two solutions for the equation. Okay, in this question, when you have this type of questions, what you generally do is take LCM and then multiply and get the numbers on both sides. You generally try to convert whatever you have or reduce the given equation into its general form of quadratic equation. What is the general form? That's ax square plus bx plus c equals to 0. So first of all, we need to convert whatever the equation it is given. We need to first convert it into this general form. So we are taking LCM of the denominators, x plus 2 into x minus 2, and in the numerator have x minus 2. You are going to multiply with x minus 2, so that's x minus 2 into x minus 2, or x minus 2 whole square you can say. And on the right side you have x plus 2, so what you multiply, you are going to multiply with x plus 2 again, so you get x plus 2 whole square, or you write it 2 times. Okay, so that's a plus b whole square. What do we get? A square, that's x square plus b square 4 minus 2ab, so a is a minus b whole square. Okay, so minus 2 into 2 4 into x minus 4x. So okay, plus a plus b whole square, again a square plus b square plus 2ab, that's 2 into 2 4x. Okay, whole thing divided by, now here you have to multiply x plus 2 into x, a plus b into a minus b, so that's a square, that's x square minus b square, 2 square is 4. Now you can cross multiply with that 4, so what you get, minus 4x this term and plus 4x. So you can see that when they add it gets 0, you can cancel them, so you have x square plus x square 2x square plus 4 plus 8 equals to 4 into this. Okay, so 4x square minus 4 into 4 is 16. So you first have to write it in the general form, 2x square, taking it to the other side we get 4x square minus 2x square, sorry, minus 2x square, minus 16 goes to this side, we get plus 16. Okay, so 8 plus 16, so we have 4x square minus 2x square, that's 2x square equals to 8 plus 16, 24. So here we don't get a general equation, but it's much easier than the general equation. So you get 2x square equals to 24, x square equals to 24 by 2, we get 12. Now you can just find out x square is this, so x is root over plus minus root over 12. Okay, so plus minus root over 12, one you get 4 into 3, so 4 is 2 square, or let me write it, of 2 square into 3, so what you get is plus minus 2 root 3. So what are the two solutions? We have x equals to plus 2 root 3, we don't have to write plus, and minus 2 over 3. So those are the two solutions. Okay, in this question, first you have to convert this into the general form. Okay, so let's try to convert this. First of all, we need x square, so we have to open the bracket first. Ax square plus a equals to, here you don't have to open the bracket because this whole thing is getting multiplied with x, so you already have a term with x. Okay, even if you open it, you'll have to multiply again anyway. So a square plus 1 into x. Now if you, a cannot be 0. If a is 0, you're multiplying this whole thing by 0 and x square gets 0, right? So there is no term of x square. That the reason is why a not equal to 0. A cannot be equal to 0. So here we have to transpose this whole term to the left hand side. So we get a x square, then we get minus a square plus 1 into x, and then plus a, it is already there, equals to 0. Now we can see that this is in the form of our general equation. If you compare, this is our a, this whole thing is our b, this is a, this is b. You should not show like this in the copy, but to make you understand, I am writing all this. Okay, and this is our c. So just to be clear, what is a, b and c. Now let's put this into the formula. So x equals to minus b, that's minus of, okay, minus b. B is this one, a square plus 1, this whole thing minus, okay, minus of b plus minus root over b square. That means this term square minus gets plus, so we have a square plus 1 whole square minus 4ac. 4 into a is a and c is also a, by 2a, and a is a only, so you have plus a square plus 1 plus minus. So you need to simplify the second part, that's this square of this. Okay, so a square square, then we have plus 1 square, that's 1, and plus 2ab, that's 2 into a square into b is 1, minus 4a square, whole thing divided by 2a. Okay, that's a square plus 1 plus minus, we say a square square, and this gets minus root over a square square plus 1 minus 2a square. Okay, 2a square minus 4a square, that's minus 2a square. So we can write this as, so that we can see that's a square plus b square minus 2ab. Okay, so you can write it like that, 2a square plus 1 plus minus, now these things, a square plus b square minus 2ab is a minus b whole square, so root over a square minus 1 whole square. If you open the bracket, you will get the same thing, by 2a, and that's a square plus 1 plus minus a square minus 1. You take it out from the root part and you get 2a. So you get two different values. That's once we are taking plus, so therefore x equals to, this is a square plus 1, once we are taking plus a square minus 1, whole thing by 2a, and the other time we're taking the minus sign, a square plus 1 minus a square minus 1 whole thing by 2a, and that's a square. If you open the bracket, a square plus a square is 2a square, and plus 1 minus 1, so 0. 2a square by 2a, and the second one is a square minus a square gets cancelled, so plus 1 plus 1 2, so 2 by 2a. So what are the two solutions we have? One is, if you get simplified this one, so you get 2a cancelled, we get in the numerator we have a, and here we have 2 cancelled, 1 by a. Okay, so the solutions are a and 1 by a. If you want to verify your result, you can just put those values in the equation. You can just put a and 1 by a in place of x, and you should find the left hand side should be equal to the right hand side. Okay. Okay, in this question we have x minus 1 by x equals to 3, and x cannot be 0, you cannot divide. So what you're going to do is you're going to take LCM. So what you get, x, and here you have x square minus 1 equals to 3. So that's very simple to write it in that general form. X square minus 1 equals to 3x, and so x square minus 3x minus 1 equals to 0. Now you can use the formula and simply find the solution. So do it yourself. This is your task. You find out the answer. Now let us try to understand this question. This is simple anyway. You just have to find out the general form of the equation. So for that, first you need to convert this into the general form. How do you convert? Now once you have this type of questions, what you can do is generally you can take LCM and go on multiplying. So that will be a bit of a longer way to solve, but this one there is a trick. The trick is when you find this part and this part to be the reciprocal of each other, you can take one as y and the other one as 1 by y. So that is what we have done. We have taken the first part as y, that's this, and so the reciprocal of this, x plus 3 by 2x minus 1, is 1 by y. So instead of writing this whole thing again, we are just writing 2y and minus 3 into 1 by y. Okay, so again this is a normal thing to solve. You can just go on and find this general form, and using the formula where our b is minus 5, c is minus 3, and a is 2. So putting the values, what you get when you solve is y equals to 3 or minus 2. Okay, so now we know that y is this, but we don't want y. What we want x. We need the value of x. Okay, so again in this question, if you see, x cannot be minus 3 and half. Why? The reason is, if you put x equals to minus 3, then this term becomes 0, and if you put x equals to half, then this term becomes 0. So any number cannot be divided by 0. That is why x cannot be equal to minus 3 or half. Okay, so now let's find out what is x. So we have two y values, so one is 3 and one is minus half. So when y is 3, we have some value of x, and when y is minus half, we have some value of x. Sorry. So these are just simple calculations. In place of y, we put the value of y here, and we find out that x is minus 10, and here in place of y, again using the same value, we get x equals to minus 1 by 5. So the two values of x is minus 10 and minus 1 by 5. I hope you understood this trick. Carefully see this question, because this type of questions generally come into the board exams where you need to find the solution correct to 2 decimal places. Now there are two types of questions. In one question you may get two decimal places or correct to two significant figures. So we'll solve one question based on that. Let us say decimal places. So we all know that means we need to find out two places to the decimal part. Okay, so whatever the answer is, we are going to keep it to that two places. Now let us first solve this using the formula. So when you solve this, you get 5 plus minus root over 73 by 8. Okay, so 73 is a positive number, so you need to find out the square root of 73. So we know that 8 square is 64 and 9 square is 81. So the value of root over 73, that means root over 64 is 8, root over 81 is 9, that means root over 73 is somewhere between. Using the division method, how do we find? We take both the numbers at a time. Okay, 7 3, so we know 8 into 8, so we'll take the smaller number. We cannot take 9 into 9 because it goes beyond 73. So 8 into 8, 64, just normal division, 9 is left. Now here comes, you have to add the same number. Okay, so 8 plus 8 is 16, and you need to put the decimal point here and 2 zeros at a time, not 1 0, 2 zeros at a time. You get 16 and 900. So you have to find this number again, how much you are going to multiply. So you are going to take those two numbers exactly same. Here see 5 I have taken, and here also it is 5. So if you are taking 164, you have to multiply this number with 4. Okay, so 165 into 5, I get 825. If I take 166 into 6, it goes beyond 900, so you cannot take it. So after subtracting, we get 75, and then you have to add the last digit. Okay, 165 plus 5, we get 170. Now 170, and since we have already taken the decimal point, so it doesn't matter, we can just go on keeping those two zeros added. So 2 zeros added, we get 7500. Now 170, so whatever number we are taking here, it is actually in thousands. Okay, 1704 here I have taken, so 4 into 4, I see 1704 into 4, I get 6816. If I take 1705 into 5, it goes beyond this. Okay, so these things you have to do a little bit of practice so that you get it by what number you are going to multiply, you'll get this number. Okay, so 6816, once you subtract, you get 684. Again I have to take two zeros. Now 1708, now I need to add plus 4 to this last digit. Okay, so 1708, now it is in 17,000 something. So I see that if I multiply by 4, 17,084 into 4, I get this value. If I multiply by 5, it goes beyond this, so I took that. And then you can go on doing that division part, but we don't have to, because what we need two decimal places, but I have taken 3 decimal places. The reason is, when the next digit is 5 or more than 5, so you have to round it off to 2 decimal places and you will get a higher digit here. So if you remember how to round off a number, you need the next digit. Okay, so if I need 2 decimal places, I should always find the third decimal place in the square root. Now just putting the value in the place of root over 73, what do we get? We get 8 plus 8.544 by, okay, so once you are adding and once you are subtracting, so on adding you get 13.544 by 8, on subtracting we subtract the smaller number from the larger number and we put a minus sign, so 8.544 minus 5 is 3.544, and since we are subtracting a larger number from the smaller one, we put a minus sign. Okay, so you need only 2 places to the decimal part. So 1 point, you see, since this is less than 5, so this digit is not changing, 1.69. Here also the number that is after the 2 decimal places is less than 5, so we are not going to increase this 4, so we have minus 0.44. so be careful with those 2 decimal places or 3 decimal places. Okay, in this question you have 3 significant figures. Let us solve it first, then I'll explain what is significant figures. Okay, so once you have the equation, so putting in the formula, we get 3 plus minus root over 89 by 10. So the same way, 89 is lying between 81 and 100. Root over 81 is 9, and root over 100 is 10. So this root over 89 has to be somewhere between this 9 and 10. So you know how to find out the square root of a number. So 89, I've taken 2 numbers at a time. 9 into 9, 81. Again 9, 9, 18. Okay, so decimal point and 2 zeros here. So 184 into 4, I get 736. 5 taken, goes beyond 800, so I've taken 4. Okay, so next is you're going to add 4, the last digit to this, so 188. Okay, 188. And here if you subtract 736, you get 64. So 2 zeros again, 6400. Now this is 1880 something. So if I take 0, it gets 0. If I take 1881 into 1, so I see that it goes 3 times. If I take 4 times, it goes beyond 6400. So we are taking 3, so that's 5649, and the remainder is 751. We can go far beyond this, but we need 3 significant figures. Okay, so significant figures means the figures or the digits that has some value for the number. Okay, so if I add a 0 here, that 0 has got no value to this number. If I add a 0 before 9, that 0 is again has no value for this number. So if I add one more number, then we get 4 significant figures. But I need 3 significant figures, so I think that's sufficient for us now. 9.43, we have already those 3 significant figures in this number here. So in place of root over 89, I can put 9.43. Once we are adding and once we are subtracting. On adding we get 12.43 by 10, and here we get minus 6.43 by 10. So on dividing again by 10, the point moves one place to the left. Here also one place to the left. So I get 1.24. Again we are not writing 3. Remember, the reason is we need only 3 significant figures. So 1 has a significance here, 2 and 4, all these digits in this number has got its value, significant place. Okay, so this 3 decides whether it has to be 4 or more than 4. So if it is suppose 5 or more than 5, then it should be 2, 5. Okay, but it is 3 less than 5, so it's 1.24. and in the same manner we have 0.643. now here you see this 0 has got no significance, so hence we need these 3 numbers to the right side. These are 3 significant figures. Okay, so here I have 1.24 and here I have minus 0.643. so this is how you write when you have to solve a quadratic equation and write the solution in 2 or 3 significant figures. Understood? I hope you understood this exercise, and this was very simple using the formula. See you in the next class.